Good morning, students. Welcome into the another session of CS02 Programming in C. As you can see onto the screen, lastly we are discussing about various types of mathematical function, and few are the left to be discussed, which is selected onto the screen. These functions are f mod, log, mod, f power, sine, and the last one to be discussed is square root. So these are the functions that we have to discuss in mathematical function as far as the syllabus is concerned. So let's start with F mode. Without wasting more time, first I would like to share one thing is that apart from all this, power and SQRT, that is square root, is most important mathematical function as far as the examination point of view is concerned, and the rest of are less important in university examination. So let's start with F mode. Now, to practically handle F mode, simply we have to change the function called f mode, which stores its output value into the resultant variable. Means what I have done in this program, first I have mentioned the necessary library function, that is standard input output dot h, console input output dot h, and all these are the pure mathematical functions. That's why I have written maths dot h. Then into the main executable statement, into the bracket, two different variables I have declared. The variable number 1 holds the inputted value, and the variable number 2 give the output onto the screen. Both the variables are declared as a double data type. Then after the basic function called CLR the first thing that I am printing onto the screen, it's a label which instructs the user to enter their value. That means there is a message, enter your value, and then there is a scanf statement which reads and stores user inputted value into the desired declared variable called a, and then I have passed that particular variable a as a parametric value into the function called fmod. So the syntax of fmod is very simple: fmod into the bracket single parametric value, then whatever the output comes stores inside the variable called result, and the printf statement will print that result onto the screen with the concatenating of the message called output is. Now let's check for the syntactical error. Now as you can see onto the screen, there are no syntactical error. Then we can proceed for the execution of the code. Say for example I am entering 4 as a inputted value, then it returns 2 onto the screen. Sorry, I have entered 2, then it returns 0.7 onto the screen, and it's there onto the screen. So as far as the syntactical part and the theoretical concern about this particular topic, output is proper onto the screen. Let's see this code in Notepad for better visibility. Let me remove this commented section so it will reduce the entire complexity of the code. So for that I have to go into the C drive, then turbo C, disk, turbo C, bin, and the code which I have saved is 9.c. So just write down the definition for this particular program. Write a program to demonstrate the use of fmod function. Again, I am revising this entire program. First three lines are the library statement. These three library statements are standard input output.h, console input output.h, and maths.h, as we are using pure mathematical functions in this particular program. Then there is a void main. It's called as main executable statement. Then there is a two variable declaration, where the first variable is inputted variable and the second variable is a resultant variable. Then after CLR SCR, there is a label which instructs the user to enter their values. Whatever the value user enters, reads and store inside the variable called A, and then that A is passed as a parametric value into the fmod function. Fmod function divides and find out the modulus of that particular value with 1.3, and it stores inside the resultant variable called result, and then this last printf statement will print that output onto the screen. Now let's check for the second function, that is log. By simply modifying just a function name into the entire code, we can have a look for the functionality of log. So what I am doing is I am going back into the C, then I am changing the function name as a log, and I am passing a parametric value called A. Let me check for the syntactical error. As you can see that there are no syntactical error. Let's execute the code, enter some value, and it returns the desired output onto the screen, that is 1.79 for the inputted value called 6. Now let's see this code into the notepad for better visibility. Write down the definition. Write a program to demonstrate the use of log function, and note down this particular program in your journals. Let's move on. Next one is mod f. To test the functionality of mod f, again I am using the same code. First I am changing the name of function, and then as a second parameter I am passing a one fractional value, that is, say for example 2.4. Let me take this entire file first, just taking it into the new file. Let's run the code. There are no syntactical errors. Let's execute. Shows the whole and fractional part are 10,000.56 and the original part is 10,000.56 followed by 3 more digits, that is 7,000. So this particular function will return the base with 2-digit fractional number only. Let's see this particular program in Notepad for better visibility. Write down the definition. Write a program to demonstrate the use of mod f function, and note down this particular program. As this is a video lecture, you can pause it. Will not waste more time for this. I'm just closing the code. The next function to be discussed is very important, called power. For that I am using the reference of my code called 8.c. So I am just reopening the 8.c. I am changing modef function with power, and I am keeping the rest of the program as it is. What it returns, 2 raised to 2, that is 2 power 2 is equals to 4 onto the screen. Let's check for some another value. 3 into 2, that is 3 into 3 is 9. So 9 will be written onto the screen, which is the power of 3. Let's see this code in Notepad. Write a program to demonstrate the use of power function. Again I am repeating my words. Write a program to demonstrate the use of power function. Note down this particular code for your journal. Let's move on. Next topic to be discussed is SIN, that is sign. No need to go in depth about this sign, just change the name of function first from power to sign, and it contains only the single parametric value as an input. It will give you the appropriate output like 0.14 for 3 onto the screen. Now let's check for SQRT. It's very important. Let me enter 25. It returns 5. So square root of 25 is 5. So it will be written onto the screen. So these are the list of mathematical functions that we have to discuss as per the syllabus is concerned. Let's go ahead. The next group of functions are even not that much important for university examination, that is date and time function. I am taking this entire list of function into the fast track. So let's write date and time function. Now all these functions deals with the current date and time. That means if I use the clock function, this function will display current date and time in long format. The syntax of this particular program is simple. Without any parametric value, use clock function. Next is diff time. This function will give the time difference between the two given times. That means if I enters two different timings, my time number 1 is 10, time number 1 is 11, then what it returns 1 is a difference. There is a 1 hour difference between these two inputted time. That is the functionality of DIFF time. Next function is MK time. In short, it is called as make time. The theory of this MK time says that this function assign new time to the variable which can be changed. Again, I am repeating my words. MK time is a make time function. This function assigns the new time to the variable which can be changed. Say for example, right now 8:37 is there into the clock. By default, whenever I assign the variable as a clock function, it takes 8.37, but I want to go before and after of 1 hour for this particular time interval, then that could be done using make time function. Next one is time. Time function will only display, that means the functionality of this function is this function will display the current time only. That means it will not display any dates. Then next one is ASC time, that is ascending time. Then next is C time, that is current time. GM time, specially for India Standard Time. Local time, it displays the time if it displays the time of local geographical area. And the next one is STRF time, that shifts the time 1 hour ahead or before. So these are the theoretical session about date and time function, which is not important as far as the examination point of view is concerned. Next one is input output formatting function, where in almost all the programs we have used about printf and scanf function. GetC, this function is used to get a single character from the user. That means this getC function will get a single character from the user and it stores inside the variable which has been declared by the user. Next is getChar. this function will keep this function will keep the array of character from the user and store inside the variable. Next is getS. As previously indicated, that getC is the function which is used to get a single character from the user, while getS is used to get a single string from the user. Next is putC. PutC is a printing statement. That means it will print the single character onto the screen. Generally, getC and putC returns the similar functionality like printf and scanf. The difference between these two is what? These two, that means getC and putC, are the pure string handling function which can only handles the single character at particular time, while in printf and scanf we can read any type of formatted data like text, character, number, or any combination of all these things. Next is putchar. This function will display the list of character onto the screen. Next is putS. This function will display inputted string onto the screen. And last one is ungetC. This function will remove the character which has been stored inside the declared variable. So these are the theories of a miscellaneous function which is used for input-output formattings. Next one is miscellaneous function. And into the miscellaneous function, first one is delay. Delay is related with time. That means it will extend the time of executing the function. This is very important for university examination, even very interesting too. Let's demonstrate this particular program. For this program, first I am declaring a one variable called a. Then after CLR ACR, let me declare I as a inputted variable. Then for is equals to 1, I less than equals to less than equals to 10 I plus plus, and into the bracket simply I am printing the value of I. We knows the output of this particular program. The output of this program is 1 to 10 number in every new line, right? Now what I am doing is I am just adding a delay function in this program with one interval of time. Just observe the output. What it does, obviously it prints 1 to 10 number, but it puts the delay of interval time in between the printing of two numbers. Let me execute the code again. 1, then sometime 2, sometime 3, 3, 4, 5, 6, 7, 8, 9, 10. Suppose I am increasing the time interval. What it does? 1, then there is a delay, 2, then there is a delay 3, again delay 4, delay 5, delay 6, then delay 7, delay 8, delays 9, delay 10, and there is a termination of the loop. Let's see this code in Notepad for better visibility. Just note down the definition. Write a program to demonstrate the use of delay function. Again I am repeating my words. Write a program to demonstrate the use of delay function. Note down this entire program. In general, for the future purpose, let's move on. Next one is CLRS here. Almost in all programs, starting from the first lecture, from where we have started with the practicals, we are using this CLRS here function. Similar type of function is clearer. What is the syntax of clearer? Let's see. This particular function will reset the error indications. That means, suppose due to some technical errors or syntactical mistakes, if compiler throws an error message onto the screen, and suppose we wish to reset the entire number of error indications, then that can be done using this clearer function. This is the syntax of using clearer function. Simply we have to pass a file pointer. Now, to practically handle this particular program, this particular function, we need to discuss about the last unit of our subject, that is called as file handling. So we'll keep into the pending. The rest of the functions, starting from this selected function to the last one, we'll discuss in next lecture. Thank you very much, students, for listening me, and have a nice day.